welcome to our last lesson, if you can believe that, for this course. So the last thing we're going to look at is what we've been building to is being able to solve exponential and logarithm equations. And you may remember, I think it was from the first lesson, that we were rewriting the two sides of the equation as the same base, and then we could drop the bases and set the exponents equal. And I said we would talk later about the principle that lets us do that, and this is where it is. It's called the uniqueness of b to the x. So if we have an equation and we have the same base on both sides, then it is equivalent to just dropping those bases and setting x equal to y. Alright, so let's look at a couple of problems. So this first one, if I want to rewrite both sides having the same base, then 3 to the x is good, and 81 can be written as 3 to the 4th power. And then by that uniqueness property, it says we can drop those common bases and set the exponents equal to each other. And this is the solution to our equation. Alright, so the next two, we're going to be looking to do the same thing. So this problem has 16 to the x equals 64. There's actually two common bases you can use here, and either of them will get you there. If you see these as base 2, you can do it that way. I saw base 4. It doesn't matter which way you do it. So I'm going to write 16 as 4 squared, and it is to the x power. And then 64 is 4 to the 3rd. Now we have those common bases of 4. So we can take the exponents 2 times x and set that equal to 3. Divide both sides by 2, and they get x equal to 3/2. Then for the last one of these, I can rewrite both sides of this one as a base of 2. So 16 can be written as 2 to the 4th, and that is raised to the x. We drop that common base of 2 and equate the exponents. X plus 3 equals 4 times x. This is just a linear equation. I'm going to subtract the x over. And then we can divide both sides by 3, and we get x equal to 1. Alright? So I've told you before that your calculator only does log base 10, or what we would talk about later, and this one is it, the natural log. You'll also find a button on your calculator that says ln of x. So ln of x has an implied base of e. So e is a number in math that has been defined. For us, all we need to know is that ln will undo e, just like log will undo an exponential. And the first thing that we're going to do is just using those buttons on your calculator. So you see this problem says use your calculator to approximate the following to 2 decimal places. So all I'm asking you to do is find the log button on your calculator and enter log 15. When I did that, I got 1.176. If we want 2 decimal places, this is the second decimal place. So that's going to round up to 1.18. And then the second one is the exact same idea. I just want you to locate the LN button on your calculator and enter LN of 15. When I did that, I got 2.708. Then again, this is my second decimal place, so I'm going to round up that 0 to a 1. Alright, so now we're going to start trying to solve some equations, and it's going to pull in a lot of the information that we've already learned. And what you're going to notice from this point forward in the lesson is we're going to be doing a lot of going back and forth between exponentials and logs. So basically, if it says solve each exponential equation, then what we're going to do is work with its inverse, which is the logarithm. So for this first one, 2 to the x equals 5, first notice I cannot write those as the same base, right? There is nothing I can raise 2 to the power of and get 5. So we need an alternative way to solve this, and what we're going to do to get that exponent down is use the inverse, and I'm going to what we call log both sides. So I'm going to write log 2 to the x equals log 5. And now we're going to use that property that we learned. In the last lesson, we found out if we have a power, that having log allows me to bring that down to the front. And then now I just have my variable. Log base 2 is really just a number. So if I want to get x by itself, I'm going to divide both sides by log 2. I know that the calculator pictures that I put here are very small. What I'm going to do is underneath the notes for this lesson, I've made a file of these calculator images that are larger, so hopefully you'll be able to see them better. I don't have access to an emulator here at home, so I'm trying to make sure that you understand how to enter these correctly. When I put in log 5 divide log 2 in the calculator, I got 2.32192. I went out that far because my instructions say to 4 decimal places. So this is 1, 2, 3, 4 decimal places. So my answer is going to be 2.3219 to 4 decimal places. Make sure whatever kind of calculator you have, you're practicing that you can enter these and get these answers correctly. And if you have trouble, please let me know so we can try to figure it out together. For number 2, we have the same problem. I have an exponential and I cannot write the two sides as the same base. So we are going to log both sides. That, of course, allows me to bring that power x plus 7 down to the front. And then this is a multiplication. It's that expression times log 4. So I can divide both sides by log 4. And that leaves me with x plus 7 equals log 6 over log 4. Now, this question in particular is one that you need to be careful and make sure you're watching how I solved, because I don't want you estimating until the end. So don't go ahead and put log 6 divide log 4 in the calculator and put an approximation down. You'll see the way I'm working this and the way I entered it into the calculator is what I'm looking for. To get the x by itself, I need to subtract that 7 from both sides. So I get log of 6 over log of 4 minus 7. And that's what you're going to enter into the calculator. When I did that, I got negative 5.70751. Then this is the fourth decimal place, so we're going to use negative 5.7075. All right, the last one, this is something we haven't seen until now. It says e to the 6x is equal to 4. So this e isn't a variable like x or y or a. That's that defined e that we talked about. It's Euler's number. So for this one, we're not going to log both sides. We're going to ln or natural log both sides, because ln and e are inverses. So in this case, that ln of e, if it was ln of e to the first, it'd just be 1. So basically what's going to happen here is these undo. We're just going to bring that 6x down. So I get 6 times x equals ln of 4. Divide both sides by 6. And then we're going to enter that into the calculator. Remember, you have that ln button again. I got 0.23104. Then my fourth decimal place, 0.2310 is what we'll use for the answer. Okay? Now my pages are going to be a little bit off from yours because I added those pictures in there. But the next problems, these are solving logarithmic equations. So remember, I told you that what we're going to be mostly doing in these is the opposite of what's there. When we had exponential equations to solve, we looked at the opposite or the inverse, which is log. And now that we have equations given in log, we're going to want to write them in exponential form. And this goes back to what we learned previously. If it's in log form and we want to write it as an exponential, you remember we can do our little E shape again, right? So this is base 3 raised to the power of 4 is equal to x. And this is our best case scenario. This has the variable equal to something that can be evaluated. So all we have to do is evaluate 3 to the 4th is 81. For number 2, we're going to rewrite it as an exponential. So I get x to the 5th equals 32. And this one isn't our best case scenario. Now I need to be able to figure out how I can determine what x is. And that property that we've had and used that says if we can get the two sides of the equation to have the same base, we can drop the bases and equate the exponents. It turns out we can also do this the other way. If we can get them to have the same exponent, we can drop the exponents and equate the bases. So this side has a power of 5, and I can rewrite 32 as 2 to the 5th. So they have the same exponent, so we can drop the exponents and set the bases equal. And then the last one of these, this one is going to be 16 to the x equals 2. So this one is more like the one that we've been doing. I can write both sides of this one as a base of 2. So 16 we know is 2 to the 4th. and I kind of like to see the 1 when I'm doing this, so I'm going to drop those like bases, and I get 4x equals 1, and then just divide both sides by 4, and we get x equals to a fourth.